All right, welcome back. So we are carrying on with lecture number 4, focusing on libraries. So generally libraries are bits of code written by you or others that you can use in your program. Python allows you to share functions or features with others as modules. If you copy and paste code from an old project, chances are you can create such a module or library that you could bring into your new project. Let's first look at the random library. Random is a library that comes with Python that you could import into your own project. It's easier as a coder to stand on the shoulders of prior coders. So how do you load a module onto your own program? You can use the word import into your program. Inside the random module, there is a built-in function called random.choice brackets sec. Random is a module you are importing. Inside that module, there is a choice function. That function takes into a sec or sequence that is a list. In a terminal window, type code generated py, in a text editor, code as follows. So I'm going to rather use a terminal in here. We don't need to write Python files here, so we can just type it out. Import random. This should be standard. Import random. Coin equals random.choice. And that is going to be heads and tails. So let's do that and then print same code just in the heads. Run this again and again, it'll get different values. And notice that the list within choice has square brackets, quotes, and a comma. Since you have passed into items, Python does the math and gives a 50% chance for heads and tails. Running your code, you'll notice that this code indeed does the function well. We can improve our code from using from, which allows us to be very specific about what we'd like to import. Prior, our import line of code is bringing in the entire contents of the function, random. However, if we want to only load a small part of a module, we can do the code as follows. So I can just say basis from random and specify the choice function, run it again, get the same result. Notice that we can import just the choice function of random. From that point forward, we no longer need to code random.choice anymore. So we can just take out random and just say choice. No, that won't work. Well, actually, yes. Oh, there we go. This one. We cannot only code choice, but yeah, it's a problem. We can only have choice. Choice is loaded explicitly into our program, saves us system resources, and potentially can make our code run faster. Moving on. Instead of the function random.randint, this function will generate a random number between A and B. So modify code as follows. So in this case, we're not going to import this one. We're going to import the whole library again. We're going to say random.randint between 1 and 10. And we get the value of 9. Notice that our code will randomly generate a number between 1 and 10. Run it again, 3. We can introduce the function random.shuffle, shuffles a list into a random order. So let's try that code over here. So we have a list, Jack, Queen, King, and we get shuffle, which just shuffles, randomly selects an item in the list. And then for card and cards, we can print that value out. Those are the items, random shuffle cards. If you run it again, you'll see that it shuffles it. It changes the order. That's what it does. Changes the order of cards. Notice that it will shuffle cards in place. Unlike other functions, it will not return a value. Instead, it will take cards list and shuffle them inside the list itself. Run your code a few times to see the code functioning. We have now seen 3 ways above to generate a random function. You can learn more about Python's documentation of random if you go to the Python documentation link of random. Statistics. Python comes with a built-in statistics library. How might we use this module? Mean is a function of this library that is quite useful. In a terminal window, type average. in the text editor window, modify code as follows. So I'm not going to create a file for this. I mean, there's only a few lines of code. We can do this inside our Jupyter library. So what does this do? Notice that we have imported a different library now called statistics. The mean function takes a list of values, or two values here. This will print the average of these values in a terminal window if you run it. Consider the possibilities of using the statistics module in your own program. So again, you can find more about it in the Python documentation. Command line arguments. So far, we have been providing all values within the program that we've created. What if we wanted to be able to take an input from command line? For example, rather than typing Python average in the terminal, what if we wanted to be able to type Python, here we go, Python average by 190, to be able to get the average between 190. Well, we can do this using the sys function sys is a module that allows us to take arguments at the command line. argv is a list within sys module that records what the user typed on the command line. Notice how you will see sys.arg.v utilized in the code below. In the terminal window, type code name.py. In the text editor, go as follows. So again, I'm not going to do this. I'm just pasting that in the block. And then, this one is a bit different because Jupyter Lab doesn't like this. So let us create a file, rather, Python file. And paste it here. And just call it name. And we're going to say send run name. And I can say Dave. There we go. That works. Notice the program is going to look at what we user typed. So I typed in the name after the file name. So we can name it Py to be more explicit, but give the same thing. Currently, if you type Python name David into the terminal window, you will see hello, my name's David. Notice that sys.arg1 is where David is being stored. Why is that? Well, in the prior lessons, you might remember that lists start at the 0th element. What do you think is held currently in sys.arg0? You guessed name.py. You would be correct. There's a problem, though, with our program as it stands. What if the user does not type in the name at the command line? Try it yourself. Just type, remove this. You'll get an error, list index out of range. An error list index out of range will be presented by the interpreter. The reason for this is that there's nothing at sys.argv1 because nothing was typed. Here's how we can protect it from a program. You can use try and except. Just in case that happens again, go to our file, and we just add a try and except statement. So if there's no input, then just input 2 free arguments. Run it again. There we go. A program can be further improved if we have too many arguments. So copy this again, pause the video, try it yourself, and see how it works. Now we want to add another situation where there's too many arguments. We don't want that. So if I say run it again, that's fine. If I say A and B and C, I'm going to say too many arguments. I just want David, for example. Notice if you test your code, you will see how these exceptions are handled, providing the user with more refined advice. Even if the user types in too many or too few arguments, the user is provided clear instructions about how to fix the issue. Right now, your code is logically correct. However, there's something very nice about keeping our error checking separate from the remainder of the code. How could we separate our error coding? Modify code as follows. You do it simply by saying sys.exit. So if you run it, we'll say this, different arguments, A, B, C, different arguments. Notice how we're using a built-in function sys called exit that allows us to exit the program if an error was introduced by the user. We can rest assured that the program will never execute the final line of code trigger an error. Therefore, sysargv provides a way by which users can introduce information from the command line. Sysexit provides a means by which a program can exit if an error arises. Learn more about from Python documentation. Slice. So slice is a command that allows us to take a list and tells the interpreter where we want the interpreter to consider the start of the list and end the list. For example, modify your code as follows. Here. Notice that if you type in Python David Carter on Linux, let's try this. Well, I just need the names. It will type in that correctly. The terminal. What it does, it takes a for loop for the arguments and types it out. So how then could we ensure that the interpreter ignores the first? So how then could we ensure that the interpreter ignores the first element of the list where named reply is currently being stored? Well, slice can be employed in our code to start the list somewhere different. So to modify your code as follows, we are going to do the following. Copy this over here, paste it, and you notice that we are slicing this list. So what does it actually do? Notice that rather than starting this at 0, we use square brackets to tell the interpreter start at 1 and go to the end of the list using 1 and the colon argument. Writing this code, you notice that when we can improve our code by using relatively simple syntax. Again, it should run. There you go. It doesn't show the name of the file anymore. Packages. One of the reasons Python is so popular is that there are numerous powerful third-party libraries that add functionality. We call these third-party libraries implemented as a folder packages. PyPy is a repository or directory of all available third-party packages currently available. Cowsay is a well-known package that allows a cow to talk to the user. Python has a package manager called pip that allows you to install packages quickly onto your system. In the terminal window, you can install or import Cowsay package by typing pip install Cowsay. After a bit of output, you can now go about using this package in your code. So I'm not sure we can do that. I mean, it's a bit of a silly example. Let's see if it will be built in. No, it's not. So in your own Python environment, you can just pip install Cowsay. The examples of the code, for example, would show, terminal window, type this, and then notice that the program first checks that the user inputted at least 2 arguments at the command line. Then cow would speak to the user. Type Python say David, and you'll see cow saying hello to David. Further modify code by saying the following. We're using Trex. Notice that also T-Rex. Now T-Rex is saying hello. You can now see how you can install third-party packages. You can learn more about PyPy's engine for Cowsay, and you can find other packages as well to do the same thing. So just for a quick demonstration, I installed this on my local machine, and I could import Cowsay, and just a very silly example, say Cowsay.hello David, and there it draws a little picture with characters and shows hello David. Then for T-Rex, hello David as well, shows a little T-Rex for hello David as well. Okay, so there's a little example of how it works. APIs, this is quite an important section. APIs, or application program interfaces, allow you to connect to code of others. Requests is a package that allows your program to behave as a web browser. In a terminal, pip install requests. Let's see if I actually have requests. Yes, I do. It should be actually a default installed, which it is. It turns out that Apple iTunes has its own API that you can access in your programs. In your internet browser, you can visit this, a link over here, and a text file will be downloaded. David constructed this URL by reading Apple's API documentation. Notice how this query is looking for a song. with a limit of one result. This relates to the term called Weezer. Looking at this text file that's downloaded, you might find the format to be similar to that we've programmed previously in Python. Format in that downloaded text file is called JSON, which is a text-based format that is used to exchange text-based data between applications. Literally, Apple has provided a JSON file that we could interpret in our own Python program. So let's code or create a file called, I'm actually going to create a file. I mean, this is also pretty straightforward stuff. Import requests and sys. And this would be the request.get. Okay, maybe, well, we want the input, so let's just create the file. Let's call this iTunes Py. Paste it there. Let's get rid of that, and let's run it. Let's run it, see what happens. Send run iTunes. Nothing happens, it seems. Notice how the return value of requests.py will be stored in response. David, having read the Apple documentation about this API, knows that what is returned is a JSON file. Running Python iTunes.py.weezer, you will see the JSON file returned by Apple. However, the JSON response is converted by Python into a dictionary. Looking at the output, it can be quite dizzying. Let's try this one. I think this is the input we needed. There we go. This is the output that we get. Turns out that Python has a built-in JSON library that can help us interpret data received. Modify code as follows. Paste this, import JSON library, and then now we're saying using the JSON library, this function dumps and converts it in a better format. Let's see what happens if you run this file again. This looks much better. Notice that JSON.dumps is implemented such that it utilizes indent to make the output more readable. Running Python iTunes.py.weezer, you will see the same JSON file. However, this time it is much more readable, and notice how you will see a dictionary called results inside the output. Inside the dictionary is called results. There are numerous keys present. Look at the track name, for example, value in the output. There's the track name, say and so. What track name do you see in your results? How could we simply output the name of that track name? Modify code as follows. I'll keep it as is, and then we just want to show the track name itself. So the only thing we do is we get the response from JSON, and then we look for something in results called track name. Right now, and we get the song, track name. Notice how we're taking result of response.json and storing it in O as a lowercase letter. Then we are iterating to the results O and printing each track name. Also notice that how we have increased the limit number of results to 50, running programs to see results. You can learn more about requests in the library's documentation in Python, and also about JSON in Python's documentation as well. Making your own library. So you have the ability as a Python programmer to create your own library. Imagine the situations where you may want to reuse bits of code time and time again, even share with others. We have been writing lots of code to say hello so far in this course. So let's create a package to allow us to say hello and goodbye. In a terminal window, type code sayings.py in the text editor. Okay, let's create a new file here, a new Python file, and sayings. Let's open it up and create two functions. All they do is they get input and they say hello to the name, goodbye to the name. Notice that this code and itself does not do anything for the user. However, if we are program, we can import this package into their own program. The abilities created by the function above could be implemented in the code. Let's see how we could implement code utilizing this package that we created. In the terminal window, create another file called say.py in the text editor and type the following. So let's create another file, which is going to use these functions we created. We call it say.py. And what we do is we effectively import our standard library, and then we're saying from sayings import to goodbye. This is the file we just created, right? Sayings.py. We just created this, and we're importing the function in sayings.py. There it is. We're importing it and using it in here. So if you run this file, if we run it, if you run it, and we say send run say David no module sayings. Maybe I have to restart this. Maybe restart it to restart the kernel in Jupyter. Maybe that's the issue. Great. Yeah, so now it worked. I just need to restart the terminal so it notices that there is a new file here in our directory. So run kernel restart kernel does that over here. There we go. So we've actually used our own library, and it works. So the code imports abilities of goodbye from sayings package. The user inputted at least 2 arguments. The command line it will say goodbye along with the string inputted at that command line. Summing up, so libraries extend the abilities of Python. Some libraries are included by default with Python and simply need to be imported. Others are third-party packages and need to be installed using pip. You can make your own package for use by yourself or others in this lecture. Then about libraries, random, statistics, command line arguments, slice, packages, APIs, and make your own libraries. Thank you very much. Hope you learned something. Until next time, goodbye.